Yeah.
Bree, close the door for me, please. Dankeschön. All right, questions on the homework? Number 10. Number 10. All right, so number 10, you're starting off with this, well, it's a triangle that's on its side, looks something like this. And you are told that, let's see, A, B, C, D, E. A, B, C, D, E. And you are told that AB is parallel to CE. AB is parallel, what? Oh, BD, I was going to say, these two things are parallel. All right, pro tip. As soon as you hear that two segments are parallel, immediately think what? Immediately think what? Immediately think, if two things are parallel, alternate interior angles are congruent, what else? We do have that, but this book never throws into that. Corresponding angles, are you listening to Maya? Yeah. Okay, now you are. As soon as you see that two things are parallel, immediately think, okay, then I know that alternate interior angles are congruent, I know the corresponding angles are congruent, one other thing. There's three of these. Yeah, that's true, but the book never uses that. It also never proves that either. We proved it. And that same side interior are not congruent at, well, on one side. Supplementary. If it's perpendicular, then they are congruent. Okay, so we're thinking those three things. Okay, let's look at the picture. Okay, maybe I make it in red. So here are the two parallel lines. Those three things. Alternate interior, same side interior, supplementary, and corresponding or congruent. Well, where are those on that picture right there? Do you see any alternate interior angles? So sometimes when the picture is messy like this, we draw it simpler. Here are the two parallel lines, and they're cut by two transversals. Here is your first transversal. It looks like that. That's the top line. Okay, where are the alternate interior angles? Where are the alternate interior angles? Here and here. Are those labeled up there? Let me do it more. Are those labeled right there? They're not labeled, so not alternate interior. What are the other two things? Same side interior. That would be this angle and this angle. They're supplementary. Okay. Maybe, maybe not. I don't know. What's the other one? Which ones are corresponding? Here's my picture. Which ones are corresponding? Well, this one corresponds to this, not labeled. This one corresponds to this, not labeled. But this one, which would be this angle right here, is the same as this one is the same as this one. If you're not paying attention, you're screwing yourself right now. Right? You're going to see this over and over and over again. Okay, that took care of this one. There's another line here. This one, same pattern. Now what can you tell me? Which angles are congruent to which angles? It's not that D is congruent to C. It's that this one is congruent to this one. Can you see the corresponding angles? Okay. Should I put one arc or two arcs? I got to put two. Why can't I put one arc? We don't. They could be congruent, but we don't know for sure, right? So I'm going to put two arcs here, two arcs here. Okay. That's your first thing. Further, it says that angle 5 is congruent to angle 6. I didn't label it, but this is 5 and this is 6. So guess what I can actually put? If this is congruent to this, then guess what? Is it two arcs or one arc now? It can be one arc, but without that statement, it would have to have been two arcs. So we got that picture right there. Okay. We got to prove that AC is congruent to AE. So we're trying to prove that AC is congruent to AE. We're trying to prove that AC is congruent to AE. We're going to go back to the previous thing. When you're asked to show that two things are congruent, what's the basic technique? We've done it 26 times so far. Well, I'm exaggerating. We've at least done it 10 times now. What do you do to show that two things are congruent? Three things. Before that, you need to show that the two parts are part of two different triangles. Then an SSS, SAS, or ASA, and then if that's like over your head right now, you've not been paying attention. If you're sitting there, you're like, I don't know what he's making a big deal about it. I don't know what to do here. You're not paying attention, right? Okay. Are those two parts part of two different triangles? They're not. So we got a big problem. We can't even use our go-to technique. So those parts are not part of two different triangles. What's this? This is called Mr. C's theorem. Mr. C's theorem says, when all is in doubt, you think about what did we do in this section yesterday? And it's probably what we did yesterday. What did we do yesterday? What were we talking about? No one can tell me what we did yesterday. We did isosceles triangle. So what's the big deal about isosceles triangles?
The two sides and the ones that are adjacent to it.
Not adjacent, but I know what you're trying to say. Opposite. So the two sides and their opposite angles are, so the two sides are congruent and the opposite side. We got two theorems, 4.1 and 4.2. 4.1 says that if the two sides are congruent, then the opposite angles are congruent. What's 4.2 say, Bailey?
If two angles of a triangle are congruent, then the sides opposite the angles.
Are these two angles congruent? Therefore, then, which ones are the opposite sides? Say again? You got to have two letters.
B and D.
Yeah, but you got to have two letters for each segment.
Oh.
So which segments are congruent? Because these two angles are congruent. Segment has two letters, not one.
B and D.
B and D is this. This is not opposite.
Oh.
Let me draw the triangle again. Hey, I'm just not drawing the center. You just showed that this angle is congruent to that angle. So what two sides are congruent? Which are in this picture, give me letters now. Karis just did it with her hand. Now tell me the letters. Yes.
Oh. What is it?
It could be, but we want to be part of a triangle. BC is not part of a triangle. A and B is, but we want the whole thing. And then you're done. So this is not our tried true technique. So I'll call it Mr. C's theorem. Like we get to like, okay, he said whenever you want to show that two things are congruent, show they're part of two different triangles, show the triangles congruent by SAS, SAS, or ASA, and then call out CP, CTC. Well, great, that works almost all the time, except for this one, it didn't work. So I always refer back to, well, when you're lost, just think about what you did in this section. Generally speaking, in homework, that's what they're going to use. The fact that this was isosceles triangle. Oh, by the way, all the steps are written in 10. You just need to put them in order. So what was the first thing that we did besides the given? What was the first thing that we did? What was the first thing we did on this proof? What did we show? We showed that corresponding angles were congruent. So which one is that? 5 and C, 6 and E, right? Corresponding angles are congruent. So it should go, well, what's the given? The given is A, I believe. Yeah. So it should go A, C. Then what do? Then apparently they're using the given D. So A, C, D, and then E. Then the last one is the statement, which would be B. Okay, so it's A, C, D, E, B. A, C, D, E, B. That's how it's done. Any other questions? Yes. Number 8. So 8 is the tricky one, which Was it this class or the other class? No, it was the other class. Other class, they got this one immediately, and they said the rest of them were hard. And I said, well, no, this is actually the hardest one. So you got something like this. You're told that these are parallel to each other. Remember that little triangle, Bree? See the little triangle, they're not arrowheads, they're triangles. If you see triangles, it means those two sides are parallel to each other. And then in the middle, you got an isosceles triangle. You got something like that. And we're told that this angle right here is 90 minus x degrees, and that the other side is 2x degrees. Okay? And you're asked to, well, tell me what x is. Okay, you're on. Whose question was this? Okay, Maddie, what kind of triangle is that? Therefore. Okay, I got that already marked. What else? So I could do opposite angles are congruent. As soon as you see two parallel lines, what are you thinking? Not supplementary, it could be. That'd be same side interior angles are supplementary. What else are you thinking? Two parallel lines, I'm going to cover everything up with that. Two parallel lines cut by this transversal, that means this angle is the same as, but this angle is the same as this angle, and now I'll cover that up. These are, so therefore that is the same as that. So we could do what? If that's the same as that, what can we do? What does same mean in math? So what could we do? And then solve for x, and that's what you got to do. So x is 30. Questions? All right. My confidence in this class is constantly shaken. We had a good class yesterday, and all of a sudden I'm back down to 0. I was at about 100 yesterday at the end of class. Like, wow, they're getting it. They got this. And now I'm back to 0. Participate. Come on. It's not a sit there and watch the teacher do the work type of class. It's you got to do the work. Right? The other thing, too, is you try. If you're not making a mistake, you're not learning. The kid that says something ridiculous learns something. The kid that keeps their mouth shut is not doing anything. You're breathing oxygen in class. And that's the only thing you're doing. Take a chance. You're not going to make a fool of yourself in this class. Right? If everybody in here was yelling out the answers and there's one kid that's saying nothing, okay, that kid might make a fool of himself because everybody else is getting it. Not in this class. No one's saying anything. Say something. Participate. Take a chance. All right, number 1 is 80. That's the value of x. It's not the degrees. Well, in this case it is, but we're just solving for x here. So I think 1 through 4, these will be the degrees, but 5 through the rest are the actual, just what x is. All right, so number 1 is 80. Number 2 is 45. Number 3 is 53. Number 4 is 11. Number 5 is 5. Number 6 is 6. Well, that's a coincidence. Number 7 is not 7. It's 41. That is the degree measurement for 7. And number 8, we just said, was 30. All right, how many people got all 8 of those correct? Okay, that's okay. How many people got 4 or more of them correct? Most hands. Okay, and Matt didn't even hear the question.
No, I didn't do it. I'm doing it tonight.
All right.
Reading this book, trying to understand this also
Number, you mean the thing that I taught you in class? Okay. Number 9, it should go C, D, B, A. Number 10, we already said, was A, C, D, E, B. And then, what did I give you through 13? I will look at your 13 and 14. I know one person who got it right. Danny, right? Has 14, right? Because he showed it to me. And it was on the board right over there. And I actually used it in 7th grade math today to illustrate why you can't name an angle, a specific thing. All right. What homework? Mine can pass out. Everyone else, Fortunately or unfortunately, today is a whole class on proofs.
Let's go. Any commercial proofs?
Let's see. We already took the quiz. Nothing going on the rest of this week. No school. I said that maybe it won't be after today. We need to do a review, but maybe tomorrow, maybe Friday. We'll see. Here is your homework. Notice it's 2 parts. Classroom exercises 1 through 9, just the odds. We're gonna do the evens in class. And then the written exercises 1 through 7. Right. These aren't all proofs, but the class is all proofs. It's not like I'm gonna have you do 20 proofs. But the class is nothing but proofs today. Many times in geometry class, we'll spend the entire class doing proofs. 2 purposes. One, I got to prove everything. That was the purpose of geometry, is to prove everything to you. And then 2, the more proofs you do, the more times you see in your force, if you participate, you force yourself to be in that zone of uncertainty, that zone of, I don't even know what's going on or where we're going, but I'm just going to go with it. I'm going to throw out a suggestion. It might be right, it might be wrong, but I'm going to throw out that suggestion. The people that get good at proofs are the people that are like, I don't know what I'm doing. I'm just going to take a shot at it. That's probably why Chandler is good at it, because he doesn't give a care, it seems like, most days. Could be right, could be wrong. I don't care. I'm going to try, though. I shouldn't talk about this since he's not here. All right. So this is other methods of showing triangles congruent. Right now, we only have 3 ways to show that triangles are congruent. What are the 3 ways?
SAS.
Right? So 3 ways: SSS, SAS, and ASA. That's the only 3 ways that we have right now. Today we get 2 more, and that'll be it for the rest of the book. Right? Okay. Unfortunately, we're going to do these in forms of proofs because I got to prove them to you. All right. Hey, take a guess at what we're trying to prove here. Read it. What's it say? Red. What's it say? We're proving angle, angle, side. So this is going to be our 4th way. Angle, angle, side. Some books call it SAA. Most books I've seen call it AAS. But you could call it SAA if you wanted to. All right, we got a whole bunch of given here. It's already marked in red on your paper in front of you. Grab your pencils. Let's see if we can do this proof. Okay? We start with a given. That takes a long time to write. So you notice in the proofs that the book did, they kind of sometimes will break their given up into 2 different sections. I'm not a big fan of that. You know, the reason why they do it is because they only want to use 1 bit of information at a time, logically sequentially. For me, I'm like, well, I'm going to eventually use it anyway. Why would they be giving it to me if I'm not going to use it? So I'm just going to get it out of the way on step 1. Either way is fine. I understand why they do it that way in the book. But you'll rarely see me ever do that. Okay. Bailey, does it say anything's parallel? We don't have any of that. In fact, we don't have anything. Look at it. And there's nothing there. You just got a bunch of red marks, and none of them say SSS, SAS, ASA. Okay? We're kind of at a loss here of what to do, right? Anybody thoughts? What?
So if you turn the triangle, both the like C and F have the same tick mark. So you say those are congruent.
It's a good idea, but that's not how we're going to prove it. He's just saying just lay one on top of the other and you're going to see they're the same triangle. Well, okay. It's not a rigorous proof, right? It's certainly it's called a visual proof, right? But it's not a rigorous proof. Like, I'm not proving it for all triangles. I'm only proving it for that triangle. I'm trying to prove it for all triangles where you have AAS.
Isosceles triangle.
Is that an isosceles triangle?
Well, no, but
Yeah, it's not an isosceles triangle. So we're kind of at a loss on this one. But we've seen this technique 1 time before. Check it out. How many angles do you have here? How many angles do you have here? If 2 angles of one triangle are congruent to 2 angles of another, you got to talk louder though. Say it one more time. allowed them. The third one, if two, there's only 3 angles, right? If 2 are congruent to 2, then the third ones have to be. A lot of books call this the third angle theorem, right, of triangles. Our book doesn't call us, I forget, it's corollary 1 to theorem 311, something like that. But if 2 angles are congruent of one triangle are congruent to 2 angles of another, the third ones must be congruent. That's a left to right. I believe, if somebody wants to look through the Book of Truth, I believe this is theorem 311. You came up with it last time, James. Isn't it 311 corollary 1, something like that? If you don't want to write that mess right there, I usually write third angle theorem and be done with it. Does that make sense that if 2 of one triangle are congruent to 2 of the other, the third one must be? We have proven that, by the way. It's because it's only 180 degrees. Okay, so we can put marks now. Now you can do this. Who's the person that's worse at proofs in this besides Bree because she hasn't done any? Who's the person that's the worst person here at proofs? Admit it. I'm worse. Chris, you're not the worst. Karis is not the worst either. She usually gets it for Bailey. All right, it's you. Bailey, look at the 2 triangles. Are the 2 triangles congruent now? Why? And you're right, they are now, but why? There's only 3 ways to show that triangles are congruent. What are the 3 ways? This is how we started class. What are the 3 ways to show that triangles are congruent? Maybe in your Book of Truth, you need to have a whole page with a big honking highlighter. You got to have these. This is not going away. This is going to be a daily thing. Help her out, Karis. What are the 3 ways? Now look at the 2 triangles. Why are they congruent? Bailey? Read with me. What's that? Do we have an angle side? No. Is it one of the 3 ways to show that triangles are congruent? Do we have an angle side? No. Karis, say again. What are the 3 ways to show that triangles are congruent? SAS, ASA, and help her out, Amara. SAS. Those are the 3 ways. SSS, SAS, ASA. Bailey, now look at the triangle. Certainly we can't go in that direction. Go in the other direction. What's it say? And you're just going to read what you see. You see an angle, you say A. If you see a side, you say S. We got an ASA. Is that one of the 3 possibilities? That's why the 2 triangles are congruent. Who beat me to that? Good. So the 2 triangles are congruent. ASA done. Boom. That was easy. Oh, by the way, what did we just prove? That there is an angle side now. So now, Bailey, how many of these do we got? We got 4 big bold letters somewhere. There's going to be a 5th one in about 5 minutes. SSS, ASA, I've already confused myself. SSS, ASA, SAS, and now AAS. Now we have 4 of them. And we just proved it for the AAS. Write that down. If you don't want to write down all those words, what must you write down? If you don't want to write down all those words, what do you got to write down in the middle? Somebody help me. AAS. We got 4 ways now. We're about to have 5. So if you are making that special page in your Book of Truth, leave room for 1 more. And there will only be 5. There's not going to be more than 5. So if you have 2 adjacent congruent angles and a side, then the true triangles are congruent. Notice it says the non-included side, so it's using those special words that we wrote down 4 days ago. The included side would be BC. So the non-include side would be either one of those sides. AES will get you into trouble. You want to know why? What if the tick mark was right here instead of right there? It still makes AAS, but check it out. The tick mark is next to the one with 2 arcs. This one is next to the one with 1 arc. AAS is the only one that will cause you problems if you're not careful. It specifically needs to be a specific side that's grouped. Now, the tick mark could be here and here, and you're fine. It's still AAS. But you just got to make sure. And when the book wants to be nasty, that's what they'll do. I would never do that to you guys because I would be happy if you came up with AAS. But AAS, you got to be careful with. The rest of them all, it makes sense. But the AAS one, you can get tricked by occasion. All right, we good? All right. So recall that to prove true triangles congruent, now we have 4 ways. We got SSS, we got SAS, we got ASA, and now we have AES. Let's get one more because why not? All right. What still don't we have, by the way? Which ones do we not have? We don't have SSA, we don't have AAA. So we still don't have those 2 right there. Okay? Okay. Here's the hardest proof of the year, right? Just so that you know, you would never be asked to do a proof like this by yourself. Okay? Don't panic. This one's a tough one. Maybe it's not the toughest one, but it's certainly one of the top 5 that we'll do this year. All right, this one's tough. Don't give up. I do want to show you one thing before, though. Is that a nice clean or is that a messy diagram right there? I mean, can you see triangles there? If I ask you to say how many triangles, you'd have to think about that for a second, right? So sometimes you're going to get a diagram that has lots of stuff going on. I would say this is a busy diagram, right? Yeah, there's triangles, there's small ones, there's big ones. And notice, there's not a word for it. If I had to choose a word, I'd say nested. Look at my hands. 2 of the triangles are nested upon each other. Can you see them? Can you understand if I ask you to tell me something about the 2 nested triangles, you might be confused because the diagram, they cover each other up. Sometimes it's hard to see the pieces parts. So here's a new technique. Guess what you do when the 2 triangles are nested upon each other? Take a guess. Yeah, you cry first. Karis, of course, gets this immediately. What's the answer? You unnest them. You separate them. So if I want you to tell me something about this triangle and this triangle, okay, some of you are going to be able to do this without doing this. But the technique is this. It's called splitting the triangle. Karis went like this. And yeah, that's exactly what you do. You just take the 2 triangles and you separate them. Now is it easier to see the 2 triangles? You don't have all this mess going on in the center to confuse you. This is an optional technique. I always use this technique, but it is optional. I would highly encourage it, though. Highly encourage it. All right, let's do a proof of this. All right, so here's the proof. Where's my diagram? What is going on there? What? I reviewed the slides this morning. There was nothing like this morning.
It's a glitch.
What is going on here? That's weird. What is that?
Thank you.
That's really messed up. Let me go to my honors geometry one and see if that one's messed up. We got problems. I'm gonna have some work to do at lunch. It's messed up too, darn it. Rats! Let me see if I can fix this really quickly. I need that one. These are not the droids you're looking for. Now you're seeing the answers. It's not going to be any fun. All right. It's still not going to be perfect, but it's close. Okay. Where is the main picture? There's one thing I hate is being unprofessional. Especially when you practice this the night before, and I have no idea what happened. That one is already there. Okay. This won't look pretty as my normal standard, but it'll work. All right, so there's our picture. We're trying to prove that two triangles are congruent, right? Can you see the two triangles inside? It's hard, right? So my suggestion is when you have something like this, split the two triangles. Draw them separate from each other. So if that's what we're trying to prove that these two triangles are congruent, draw them on a separate sheet of paper somewhere. So I just did it. And this should not be there because we're about to show that. Okay. All right, well, let's see. We're given that H is congruent to I, so mark and mark. We're given that GJ is congruent to this part. We're not given that. That's what we're about to show. Okay, this is a problem. You remember when I gave you two triangles and they share a common side? If they share a common side, what do we immediately say? Because of, this is the same thing except it's with angles. Notice that both triangles share one thing. What do they share? They share angle G. So we could say that G is congruent to G. And there's my picture now. Correct. So, please give me patience. All right, reflexive property. I apologize. So G is congruent to G. Where's my other triangle? Darn you. Run! And it's there. Why didn't it just not appear? No, I have no idea what I did wrong here. Picture. Boom. All right, now it's going to be nice. There we go.
Yay.
Okay, reflexive property. So are those two triangles congruent? Why? Well, the G is the same as G, but what are the four ways we prove the two triangles are congruent? It's not an isosceles. There's no two sides that are congruent. Give me the four ways. SSS, SAS, ASA, or AAS. Why are these two triangles congruent? AAS. Okay. AAS. 1, 2, 1. 1, 2, 1.
I was trying not to do that.
This is easily done when the triangles are split from each other. It's harder to do if you just stick with this diagram. So unfortunately, and I'll apologize for the fourth time, this is a technique that you got to remember how to do, splitting the triangles. It's usually only triangles. We're not going to be splitting squares or something like that. We will use this technique again, hopefully, and I will have my diagram correct. Yes?
The top one up there, could you say it was angle side angle as well? Could you it being combined like that?
Where is the other angle? So remember, it's got to be the two angles and the included side for angle side angle. I do see two angles.
My mind's messing with me.
That's why you split the triangles, because your mind will mess with you. Thank you for doing that. All right, write this down, box 3. It's debatable whether this needs to go in your book of truth unless you literally were paying no attention the last 3 years of your education. Do you know what a right triangle is? Okay. So debatable whether you need to put that in your book of truth. There might be some things you need, and the book will use these. I'm going to label some pieces parts. I'm never going to give you a vocabulary test, but I will use the vocabulary, so you might want to put it in your book of truth if you need it. Who remembers the parts? You did this, right? You did this in pre-algebra. You did this in Algebra 1, Pythagorean theorem, remember? We're not getting Pythagorean theorem today. What are the parts of a right triangle? What are the parts of a right triangle? Well, we've got a right angle. It's always two acute. You never have an obtuse angle in a right triangle. So it's two acute angles in a right triangle. The sides get special names. You remember?
I know one of them is a
Which one is the hypotenuse? Describe it.
The one on the
One that's slanted.
yeah, the one.
Okay, well, I'll turn it sideways, and then the other two sides will be slanted.
The one
Which is the hypotenuse?
that connects like.
Oh, so you already know all of the names. The hypotenuse we describe as being
What I was going to say is the
one not connected to the right angle. That would be a perfectly fine one.
Uh,
We're going to say the one that is opposite the right angle. The other two, as she said, were called the legs. Good job remembering that. We're going to use these words a lot, right? If you need to write this down in your book of truth because you don't have this memorized, that's where it needs to go. Okay? The legs are the two sides that make up the right angle. The hypotenuse is the side that is opposite the right angle. Dan, you writing this down? In here? Okay. Yeah, but I'm saying you got leg and hypotenuse. We're going to use these terms every day from now on. Every time we have a right triangle, I'm going to say, look at the leg. How big is the leg? Look at the hypotenuse. How big is the hypotenuse? Or what's the name of the hypotenuse? We okay? All right, this is an ugly proof. Second ugliest one in the book. Hey, we got two right triangles. Looks very easy, right? Let's see what we can prove. Right triangle. Hey, what are we given? Read it, Bailey. Red to red. Read me the red marks. What's it say? Side angle. So we got donkey, right? These two triangles are not congruent by what we know so far. Yet guess what it's asking us to do? It's asking us to prove that the two triangles are congruent. It's asking us to prove that the donkey thing is true. Now listen carefully. I don't want to be misunderstood. What kind of triangle? Turns out that for right angles, angle side is true.
What?
For right triangles, angle side is true. That's what we're about to prove, by the way. What did I just say? For right triangles, angle side is true. I'm being called because I'm cursing in class, bro.
You're welcome.
No. Mr. Chartier's. Yep. Sweet. Cool. Thank you. Seth, you're in big trouble. Okay. You can't confuse this. There is no angle side unless it's a right triangle. And the book isn't going to call it angle side. All right, here we go. We're going to prove this sucker.
Perfect. Can I run in the locker?
Yeah. So, well, there's our given. We got C is congruent to F. Why is C congruent to F, by the way?
Oh, because they're both
Okay, because they're both right angles, and 9 degrees is 9 degrees, right? And the dean's here to hear me curse, so why don't we? Literally, we just spelled out ASS, right?
Donkey. You still have donkey.
We don't, and that's not one of the 4 things, so this is a problem. This is a problem. So we have to, thank you, Donkey, for, we got to prove it a different way. What are the 4 ways we have to prove this? SAS, ASA, SSS, or if we can get one of the AAS, one of those, then we're good. So this is the hardest proof of the book, right? It's going to get ugly. Stay with me. I usually don't have kids write it down, but you got to promise me you stay with the logic. No, you'll never be asked to do a proof like this on your own. I'm going to do a construction. Notice how small my text just got? Because I need this amount of space to do this. Okay? I'm going to make a new triangle. I'm going to make a new triangle. Here's my new triangle. I'm going to make a new triangle that looks like this triangle. Not like this, but one that looks like this. And I'm going to connect it to this. Okay? Here's how I'm going to do it. I'm going to extend line DF, and I'm going to make it that long. I'm going to extend CF, and I'm going to make it that long. That's what this says. It says extend DF that far, AC. Okay? Once that's done, I'll call that point G, and I'll connect it to E. I made a new triangle. See that? Here's my goal. I want to show that blue triangle is the same as this triangle. I'm going to ignore this one for right now. Blue triangle is the same as this triangle. You with me? Straight line, right? So how many degrees? Okay, that was easy. Since we made this the same as this, I can put tick marks. Yes? I made this specifically that long so that part's congruent to this part. You said this angle is what? Okay, so is the blue triangle congruent to the red triangle? Or whatever color you want to call this one. Why? Well, we got four things we can call. Why is this one congruent to this one now? Because of S. Because of SAS, right? I know that that one's 90. Now I have an SAS. Remember, I'm ignoring this triangle. I'm going this triangle, this triangle. Bailey, you're supposed to be paying attention. Okay? So those two triangles are congruent. Everybody good on that? If this triangle is congruent to this one, and there's one tick mark here, what can we put right here? Y. This triangle is congruent to this one. And there's one tick mark here. What can we put right here? Y. Because of CPCTC. We just showed that this triangle is congruent to this one. So anything on this triangle we can put on the blue one. Well, this one had one tick mark. We put one tick mark. We're almost there. Have we said anything about this triangle now? Not yet. I'm trying to actually show that this triangle is congruent to this triangle. I made a new triangle. Seems complicated. This one is. It's really complicated. Look at this whole thing. What do you notice? What's this chapter about? What do you see? I see an isosceles triangle. So what can you tell me about angle D and angle G? But wait a minute. This triangle is congruent to this triangle, so what can you tell me about G and angle A? They're congruent because of CPCTC. So you just showed me that G is the same as D is the same as A. Two reasons. Well, this is congruent to this by CPCTC, but G is congruent to D because it's an isosceles triangle. So there's two reasons there. So what? What did I just do? You just showed that, well, I think I got the marks here. You just showed that, there we go. See the marks? Ignore the blue triangle. What can you tell me about the two black triangles now? Ignore it. What can you tell me? Do you see SAS? Where? I see a side, angle, side. There's nothing here. So it is not SAS. Yeah, but we haven't proven SSA yet. Do we see an SSS? 1, 2, 3, 1, 2, nothing. No SSS. Do we see an SAS? Sure, right. SAS. This one's not marked. So there's no SSS. What else do we see? What do you see? Where do you see an AAS? A, S. Square, arc 1, square, arc 1. They're congruent because of AAS. So what did we actually just prove for the whole thing? We proved that ASS is true. No math book in high school is going to write the word ass and say, you know, hey, you can use that in a high school classroom, right? So guess what they're going to call it? They're not going to call it SSA either, because in every kid in high school, look, it's ass spelled backwards. Right? And donkey would make sense. They don't. So they call it hypotenuse leg because it's a right triangle. So you just showed that the hypotenuse and the leg, by the way, this does spell ASS, right? ASS. But no one is going to do that, so they call it hypotenuse leg. You've got to remember that this only applies to right triangles. The other four apply to any triangle. SSS, SAS, ASA, AAS. But hypotenuse leg is only used for right triangles. So yes, we do have an ASS, but just for right triangles. And I've said that word too many times. I got to stop. Okay. So do you need to write the words down, or do you just need to write HL? You got to know how to use HL. It's got to be a right triangle. It's got to be a hypotenuse, and it's got to be one of the legs congruent. It's the easiest one to use because you see it, you say, oh, look, right triangle. I just need the hypotenuse and one of the legs, and I'm done. Be careful. It's got to be the same leg on both triangles. If you've got a short leg and you've got a long leg, just like an AES, you got to be careful. It's got to be the same leg that's congruent to each other. If it's a short one on one and the long one on the other, it's not hypotenuse leg. But if they're both the short ones or both the long one, or maybe it's an isosceles right triangle, then it doesn't make a difference. Who have I confused with that? So we do have angle side triangles. And I promise I won't show you that again. Okay. So somewhere in your book of truth, in big bold letters, this is what you got to remember. That's everything that we have, except be careful, we still don't have angle, angle, angle. And technically we don't have this, right? Because hypotenuse leg only applies to right triangles. Who's lost? Guess what the homework will be tonight? You remember the quiz? Do you remember the worksheet? They're going to give you that again. They're going to be a little bit harder. Don't forget, you can always use reflexive property to get a side. You can also use reflexive property to get an angle as well, too, if they share a common vertex. You can also use vertical angles. You can also use the fact that two angles that are next to each other on a line make 180 degrees. All of that will be useful. To include the one from 2 days ago, where if you have an angle bisector of an isosceles triangle, it bisects the base side. It bisects the base, I should say. Okay. I said you're going to have the odds. Let's look at the even ones really quick. Lots of proofs. Let's take a look at the even ones. Congruent, not congruent. Why? There's no side, angle, side there. Congruent, not congruent. Why? Well, where's the hypotenuse? Oh, it is marked. Where's the leg that's congruent? This one's reflexive. So I have the hypotenuse and the leg. So this one is HL, number 2. Number 4, congruent, not congruent. Tell me what it says. Bailey, read it. The red, read it. Don't look at me, look at the board, read it. Not because I don't want you to look at me, but I want you to look at where the answer is. Read all 3 marks. Read what's in red. What is that? What's that? What is that? Do we have an angle, angle, angle? So are those congruent? No. Number 6, congruent, not congruent. Congruent, not congruent.
HL.
Reflexive, HL. Last one, number 8. Congruent, not congruent. Well, hey, we got an angle, side angle. We just got to make sure it's, yes, it's good to go. Good to go, angle, side angle. This one is not, or could it be hypotenuse leg as well too? Because reflexive property, this could be hypotenuse and leg. ASA or hypotenuse leg. All right, wait 30 seconds and then leave. Because you're supposed to wait 2 minutes after the bell before 9th and 10th graders are released. All right, e-learners, if you have any questions, let me know. Yes.
Wonderful.
Wunderschön.
Ah.